Hey guys, previously we've been talking about, or we studied the sets in general, and we didn't get to finish everything about the sets. And to quickly recap, we uh, we came to know that we have integers. Integers could be positive and negatives from zero to I don't know, from negative infinity to positive infinity. And if you're talking about computer stuff, that's a different story, but let's assume it's purely mathematics now. And if you decided just to choose the numbers, positive numbers, 1, 2, 3, 4, those are called natural numbers. Sorry, positive numbers, or and the natural numbers include the number 0. The rational numbers um, numbers that can form a fraction. Basically, 5 is a rational number because it can be presented as 5 over 1. And you can think of them as floats, but floats that have fraction representation. As given that n, which is the fraction, uh, n is not 0, irrational numbers are floats but do not have or cannot take the fraction form like the pi. Real numbers basically host everything, positive, negative floats, etc., etc. Complex numbers can even host irrational numbers that take forms like square roots and stuff like that. So, and subsets. A is a subset of B given every element in A is also an element in B, and a proper subset uh, is considered a proper subset only and only if all the elements in A exist in B, but there is at least one element in B that doesn't exist in A. And an element, a set of say 1, 2, 3, is considered a subset of its own. It's like a duplicate. It's a subset of its own self. It's a proper, but it's not a proper subset because the elements are identical and exactly the same number of elements within the set. And an empty set is a subset of every other set. So that was the what do you call the summary, and the way we decided that an empty list is a subset of every list is because the rule says to be a subset, every element of A has to be in also an element of B. And assuming A is an element in is an empty set is a subset of B. An empty set is A and is a subset of B. Every element in B, or um, all the elements in A, has to exist in B. Now you can choose any element from the empty list and you will still find it because basically there are no elements within A. So by default, it's part of basically the rule by negation. So there isn't an element in A that doesn't exist in B. Yeah. With that in mind, we need to proceed. I think basing on the previous lecture, it seems that the book is quite interesting for those that have a bit of knowledge. But since we've decided to start from point blank, point zero, we decided this resource is way better. It's called Maths with an S is fun.com. So we should keep going through the details. We're basically about done. So we're going to go through the exercises and um, more of the stuff on Venn diagrams, sets index, and so on and so forth. We'll go through all of that. For now, we should have this up for our notes and we shall begin. So an order. Now we decided that an empty set is part of all sets, is a subset of every other set. And now we're talking about the orders. So an order does not mean the location or the position of an element within the set. It just simply means it does not matter what order the elements are in. Okay, so an example, we have 1, 2, 3, 4 is the same set. Yeah, of course. When we say order in sets, we mean the size of sets. It's also called cardinality, so this is quite important. So we can have this as a note here when we say order in sets. When we say order in sets, we mean the size of the set or cardinality. A finite set has a finite order or cardinality. An infinite set has an infinite order. Okay, I think we could. For finite set of orders, for finite sets, the order is the number of elements. It's the size of the set. Or not simply put, number of elements. So in this case, we have 10, 20, 30, 40. So 4. So we can have this as a note for us to remind us. Apologies about that. Could have this here. Apologies about the weird sounds coming out of the mic. It just fell off. Anyways, so for infinite sets, all we can say is that the order is infinite. Oddly enough, we could say with sets that in a more advanced topic in sets. Okay, so this is for infinites. It's a different topic then. Okay, fair enough. Alright, this is what I like about this website. It's actual fun. No more annotations. Just kidding, no more annotation. It's pretty awesome. I really like it. Anyway, so let's start with the questions now. So, which of the following sets is infinite? The set of all numbers less than 10. Yeah, this is an actual infinite. The set of integers less than 10. The set of factors of 10. I mean, all of them are. No, the right answer is C. Now, the set of all numbers less than 10. What did we do wrong? The set of all numbers less than 10 is finite. Okay. Whole numbers. Oh my god. It just says whole numbers. I've been reading this over and over. What's wrong with me? Yeah. Set of prime numbers less than 10. But I think it's a bit vague here because you know what? Let me just check this one out. Is -1 a prime? So let's check out -1. Is it a prime? It's not a valid number. Try again. Oh, are positive known? Like, what is so basic concepts? Oh my god. So prime numbers have to be positive. Negative integers cannot be prime. Oh, this is an important note. Prime numbers must be positive. So that's why I like this. This is what I like about learning it. And there's always something missing that you think you know, but it turns out you have no clue what's going on. Anyway, a set of prime numbers, so that's fair enough. A set of factors of 10. Factors of 10, that's like all the multiplications of that lead to the number 10. So you got 1, 2, 4, 5, and 10. Yeah. So that's true, that's finite. Set of integers less than 10, and this is, you got an infinite negative and an infinite, and till then an infinity to the negative side. Well, okay. A is a set of factors of 12. Okay, factors of 12. Which of the following is not a member of 12? Is not a member of 12. Well, definitely it's a 5. Okay, so we got 1 multiplied by 12, that's 12. 2 multiplied by 6, that's 12. And then we got the 4, and then we got the 3. So we got the list of 1, 2, 3, 4, 6. So 5 is not a member of 5. Yeah, that was just an easy one. X is the set of multiples of 3. Okay. Y is a set of multiples of 6. Okay. Z is a set of multiples of 9. Alright, so okay, which of the following is true? So we got a subset and we got the symbol. So definitely X is a subset of Z. So X is a subset of Z. Now Z is a subset of X, that's impossible. And because there are numbers, oh yeah, one second. So in this case, Z is a subset of 3 actually. A subset of X, because multiples of 3 would actually lead you to 9, but there are elements in X that do not exist in Z. So Z is an actual subset of X. Z is an actual subset of X. Z is a subset of Y. Well, not necessarily, because there are multiples in, say for example, 24, or without 24, 12. 12 is not a multiple of 9, but yes, it exists in 6. So not all elements of Z exist in Y, so this is not true. And X is also not true, because 3 does not exist in the major subset of 6. 3, for example, 3 doesn't exist. And also 6, I mean, 3, multiples of 3 is like 3 and 9. So 9 does not exist in the multiples of 6. So this is not true, this is not true. And we're left with X is a subset. No, actually Z is a subset of X. Alright, that's good. So we got X being multiples of 3, positives and negatives. This is something we should have. We should always keep in mind, positives and negatives. 6 multiples of 6, Z is a multiple, Y is multiples of 6, yeah. Every member of Y is also a member of X. So every member of Y is also a member of X. Every member of Z is also a member of X. So Z is a subset of X. Therefore, only answer D is correct. I'm not sure why Y is a. So now we know this. We know this is another deal. This is a set of multiples of 3. So 3, 6, 9, and then we got like 12 is also multiples of. So yeah, our company is still. Oh yeah, fair enough. That's good. Moving on. A is the set of positive factors of 6. Positive factors of 6. So it's like 1, 2, 3, 6, and so on. B is the set of prime factors of 6. Prime factors of 6. So there's also positive, and it only has 1, 3. So there are no 2's there. Okay, so is the set of positive. So B could be a subset of A, but not the other way around. C is the set of positive proper factors of 6. D is the set of positive factors of 3. Positive factors of 3. Okay. Which one of the following is true? Interesting. So set of prime, A does not equal B. This is wrong. Then we got positive factors of 3. A equals 3, so is the set of positive proper? So I think A is equals to 6. I mean, I don't think there is something called proper factors and positive factors. So B equals C. B is the set of prime numbers of 6 and a set of positive factors of 3. So this does not equal B. No, I can't. Let's think of an example. Proper factors of 3, like prime numbers. Oh, could be true. I think I'll go with A to C. Seems the most. Oh, actually, B to C. So prime factors of 6 and proper factors. Oh my god. What? It's a set of positive factors, so we got like 1, 2, 3, 6. That's a finite set of numbers. Only 2 and 3 are prime numbers. So yeah, this doesn't really fit. Therefore, B, the set of prime factors, the set of prime factors of 6. Oh my god. Why did I think 2 was non-prime number? I can't divide. Oh my god. What is wrong with me? Wait, is 2 a prime number? Oh, my math is so rusty, man. My mathematics is terrible. Seeing this now, it's like, but whatever. This all, going through all of this brings the memory back. That's good. Okay, so the positive proper. So therefore, okay, so we have 1, 2, 3, and 6, and then the prime set of prime factors of 6. So it's only 2 and 3, and then the positive proper factors of an integer, the set of positive proper factors of 6. So the positive proper factors of an integer do not include 1, and the number and the number itself. Therefore, oh my god, so these concepts are kind of driving you off the game here. So in this case, a proper factor, so the positive proper do not include the number 1 and the number itself. So that's what proper means. And dude, we've in the definition, no, it has nothing to do with the definition of proper sets. Proper sets is like when the superset has an element that doesn't exist in its subset. Okay. I need to understand what is proper in maths. Denominator, the denominator, the number on top is less than the denominator, proper factor. Oh man. So we have proper fraction. Okay. What is a proper number? Perfect number. Positive integer that is equal to the sum of its proper divisors. Small and perfect number is 6. What is the sum of 1, 2, and 3? Perfect number. So it's like 5 plus 1, the sum of its proper divisors. Got it. So in this case, we've got a few things we need to consider now. Okay, so positive proper factor. So let's see what proper factor means. That is, proper factor is a factor of other than 1. For example, 2 and 3 are positive, factor 6, but 1 and 6 are not. Compare the term proper divisor, which means a factor of other than but including 1. Definition of proper factor. Any of the factors of a number except 1, or the number itself. All positive factors of 12, 1, 2, 3, 4, 6, 12. Proper positive are you exclude the 12 and the 1. So 2, 3, 4, 6. Got it. A fraction. So proper factors of an integer do not include. So we should give this an example. This is a nice example. I like it. Well, all examples are good, so whatever. We're gonna do this. Now going back to what's really important. Now that drove us off a little bit, but well, we should keep going. So there's a set of positive proper factors, so it's 2 and 3. So 2 and 3, and the set of prime factors of 6, 2 and 3. D is the set of positive factors of 3. Positive factors of 3. So it's 1 and 3. So therefore B and C, fair enough. Which one of the following is the null set? The set of subsets of the null set? No, damn, that's so true. The set factors of 7, the set of even prime numbers, the set of even prime numbers, that's still the set of rational expressions for pi. That's definitely, oh my god, that is not right. What? The set of subsets? Oh my god, what is wrong? I should focus. The null set is a subset of itself, duh. So the set of null set has one element, which is the null set of itself. Oh my god. The set of rational expressions. We know that irrational. Come on, dude. This is what we talked about here. What is it? Yeah. Rational numbers and irrational numbers. If you go to the end, there's a pi there. Oh my god, what's wrong? Set of irrational expressions for pi. Yeah, that's correct. You have answered this before. Yeah, I just want to believe it. Oh my god. The rational is an irrational, so it cannot be expressed as a rational number, although we often approximate pi to 20^7, which is not an exact value. So the set of rational expressions for pi is the null set. Rational expressions, basically, the fraction, anything with the fraction form. Question 102 correctly. Boy, that's bad. A, B, C, D. How many subsets does the set A have? How many subsets? Now, A, B, C, and D. It's like 4. It could be 4 factorial. It could be MB, it could be B and C, it could be D. So we've got 4 elements, and then each element could be a subset of its own. 165. Oh my, why did I click 65? One subset with a 0 element is the null, then subset of its own, and then 2, and then, well, I knew this, but it's like I just randomly clicked. My bad. So we've got the 3's, and then we got the 4's, so it's total subset 4 factorial, 4 multiplied. What's a 4 factorial? Just for the sake of it. See if 4 factorial equals 16. Oh, it's not true, so it's like 4 by 3 by 2 by 1. Oh my god, I feel like my memory is so rusted. It's so rusty. Uh, Anyways, we should keep going. So the number of elements in this case is 16. Remember that order doesn't matter, of course. So for example, A, B, P, and E are the same subsets. The number 1, 4, 6, 4, and or I binomial coefficient occur in the fifth. What is this? I binomial coefficients occur in the fifth row of Pascal's triangle. Subsets. How many proper subsets does the set S have? Proper subsets. So that's like 1, 2, 3, 4. That's a single set right there. So we have, so in this case, a proper subset. It doesn't. This has to be. So it could be A, it could be B. So we have 5 there, and then we have 2, 2, 2. So it's 2 to the power of n. That's 2 to the power of 5, and so we go like we could subtract 1, but okay, so we have like 5 here, and then 5 subsets, and then we have like 1, 2, and then we have like 1, 2, 3, 4, and then it's like 9, 10, then we have like 11, 12, 13, then 14, and then 15, and then we could go like 15, we could go like 18, 16, and then we could go like 17, and then we could go like 18, then we could go like, so it could be, could it be 2 to the power of n minus 1? No, I'm not sure, to be honest. And then we could go like, so I'm guessing it's 31, because we also have the four combinations. So we have like 4, and then we have like another, so we have 4 to here, and then we have 4 to here, and then we have A including in the fourth. So I'm guessing it's 2 to the power of n minus 1. Could that be true? So we could go like 25. So 32 minus 1, so that's 31. 31. One subset is 0, and then 5 subsets with 1 element, and then 10 subsets with 2 elements, and then 10 subsets with 3 elements, 5 subsets with 4 elements, and then 1 subset with 5 elements. 32, but it's the same set. So remember that order doesn't matter. The numbers 1, 5, 10, 10, 10, 5. and 1, so that's like 1, 5, 10, and then the reverse of it are binomial coefficients, and according to the sixth law of Pascal's triangle. I'm not sure what's this. I'm not sure if it would be important to know now. In general, I just said that's a proper subset. Sets, and then 2n minus 1 for proper subsets. So we could go like, go secure it more. Next question. A, B, and C are three sets such that A is a subset of B and B is a subset of C. A, B, C are three subsets. I do apologize about that. What is wrong with this? Alright. A, B, and C are three sets such that A is a subset of B, B is a subset of C, A is a subset of B, and B is a subset of C. So which one of the following statements must be always true? Before looking at the answers, so A is a subset of B, so every element in A exists in B. B is a subset of B is C, every element in B exists in C. So A is a subset of C. No, A is a subset of C. P is the set of factors of 5. So we have 1, 5. Q is the set of factors of 25. 5, 25. R is the set of factors of 125. So P is a subset of P is a subset of R. P is a subset of R. Q is also a subset of R. And then R is a subset of P. And P is a subset of Q. So by definition, all elements that exist in the subset must exist in the superset. Factors of 5. So we have 1, 5, 25, 10. So it's R is a subset of so because we have 1, 5, then 1, 5, 25, 1, 5, 25, 125. Every number of P is also a member. Okay, so this is the false statement, because factors is what makes up the number. And then the next question, so we got one more. So A is a set of prime numbers less than 10. A is a set of prime numbers less than 10. Okay, so we got 1, 2, 3, 5, 7, and B is the set of odd numbers less than 10. Odd numbers. So we've got the 9 that exists in B doesn't exist in A. C is the set of even numbers less than 10. Okay, so how many of the following statements are true? Okay, C means is a proper subset of, so A is a proper subset of B. That is correct. A is correct. B is a proper subset of A. Nope, because 9 doesn't exist in A. A is a proper subset of C. Even numbers. Nope, that's not true. C is a proper subset of A. Not true. because we have 6 does not exist in the set of prime numbers, and yet it is in C, so we can't say C is a subset of A. B is a subset of C of odd numbers. No, because we have the 5 that exists in B doesn't exist in C. C is a subset of A. No, of course not. So it's only one. We choose A, but this is the correct answer. Wait, isn't A is a subset of B? Because we have, oh yeah, we have the 2. 2 is not a prime, it's not an even number. So 2, 3, 5, so I should write it down to be able to swipe. I can't keep it in visuals. Okay, that's none. I really should write down the sets, because just thinking about them, like trying to solve these equations from the top of your head is kind of messy. Now look at the disturbing result. Oh my god, it's like 50%. You need 65% AML. Oh my god. Well, should we do the quiz again? Now why do you want to do it? To earn a medal or to want to learn more? Because I felt like, but I think most of my I think the mistakes I've done are mostly because I didn't write anything down. If I wrote the sets down, I would have probably made a better result. So we could go like really faster on the second one, like give it another try and see if that's the case. Or I'm going to write down the answers this time though and see if anything changes. Alright, then, let's restart the quiz. Okay, so we've got 10 questions, and we should take about a minute for each question. Well, less a minute too much, but let's go ahead. Which one of the following set is infinite? The set of whole numbers less than 10. Is this the same question? Is this the same list of questions? I think it is. Set of whole numbers less than 10, that's not an infinite. Set of integers less than 10, that's infinite. Set of factors, yeah, that's infinite. So the factors of 10 is like 1, 2, 5, 10. Next question, A is a set of factors of 12. So we got 1, 2, 3, 6, 12. Which of the following is not a member of A? The 5. That was easy. X is a set of multiples of 3. Y is a set of multiples of 6. Z is the multiples of 9. So 3 is a starting point, 6 is a starting point, 9 is a starting point. 9 is a subset of Y, and Y is a subset of X, and Z is a subset of X. X is a subset of Y. Z, no, that's not true. Z is a subset of Y. Not true. Not true. No. Z is not a subset of Y. X, because we have like 6, and then it goes like to 12. The 9 doesn't go to 12. Okay, so 9 multiples. You've got like 18. That exists in the list of. So if you go like multiples of 9, 81, 3, then we got 9. So that's Z is a subset of X. And there we go. Multiples. So we've got the negatives and the positives, and then we've got 0, 3. 0, 3, 0 is always included, yeah. Multiple. So 3 and 3, 6, 6 and 6, that's like 3 and 3 and 3, that's 9. 6, and then we've got 12 on the Y, so 9 and then 18. So there's some elements in Z 18 exists in Y, that's for sure. Every element of Y is also an element of X, so Y is a set of X. Every element of member Z is also a member, so Y is a subset of X. Next question. A is a set of positive factors, so we've got factors 1, 2, 3, 6. B is a set of prime, so let's write it down. So we've got a set of positive factors 1, 2, 3, 6. So, and then a set of prime factors, so 1, 2, and 3. And then a set of positive proper factors, so we've got 2 and 3. These are positive factors of 3, so we've got 1 and 3. So which one of the following is true? Set of prime factors of 6, prime factors of 6. C is a set of positive proper factors of 6. A proper factor excludes the 1 and the number itself. So if you exclude the 1 and the number itself, we'll be left with 2 and 3. D is the set of positive factors of 3, and then we've got 1 and 3. So A is a set of positive factors, 1, 2, 3, 6. C is a set of positive proper factors of 6, so we eliminate the 1 and the 6. Set of prime factors is 1 a prime number? Prime numbers, oh my god. One is not a prime number. So in this case, the correct answer, B equals C. Yeah, so the prime number is not 1. It's basic math. Which of the following is the null set? The set of subsets of the null sets? A null set has a subset of null, that's something we've seen. The set of even prime numbers, we have the 2 in the even prime numbers. The set of factors of 7. This set of factors of 7, we've got 1, 7. 1 is included in a set of rational expressions. Now this is something we've seen and we've thought about it, that's why the question has been repeating itself. So we know irrational numbers and pi is an irrational number because there is no exact fraction representation that gives an exact result. See, we've got 1 and 7 there. A, B, C, D. How many subsets does the set A? Now we know it's 2 to the power of n to get the number of, because we've got 1, 2, 3, there's a 4, and then 2's, and then 3's. The number of sets of 1's, 2's, and 3's, and 4's. And it's 2 set of elements. So 2 to the power of 4, that's 16. Alright, so how many proper subsets? So it's -1, so it's like 31. I think we've answered these. That's why it's a bit easier for us this time. ABC. The ABC are three such as that A is a subset of B, B is a subset of C. So A is a subset of C. P is a set of factors of 5, so we have 1 and 5. Q is a set of factors of 25, so it's 1, 5, 25. And then 125, which is the following, is false. So P is a subset of Q, that's true. Q is a subset of R, that's Q, that's true. R is a subset of P, that's not true. Because there are numbers in the 25 that obviously they don't exist in the P. Next question. We know the answer is none, but let's go through the question again. A is a set of prime numbers less than 10, so we got 1, so 1 is not a prime number, so 2, 5, 7, 2, 5, 3, 2, 3, 5, 7, and then odd numbers, so it's 1, 3, 5, 7, 9. C is a set of even numbers less than 10, 1, 2, 3, 4, so it's 2, 6, so 0 is included, 2, 6, and 8. So A is a subset of B, that's not true. B is a subset of C, that's not true. This is a subset of A, that's not true. A is a subset of C, that's not true. C is a subset of A, that's not true. B is a subset of C. No, it's not true, because we've got the 3, for example, that's not even a number. And C is a subset of A, that is also not true because of the 3, because of the 6 and the 8s. So you can't really go and, so it's none. It's not cheating. Alright, quiz results. I got 100%. You passed the quiz. Oh my god, I did pass the quiz. I think we passed the quiz, but I feel like, I don't know, I feel like we should have paid more attention to the questions. It seems like we've made bold mistakes there. That could have been avoided easily. But anyways, we're through the sets, we've done the examples now, and remember that the order of the set means we've came to learn new concepts about it. Mathematical terminologies like the proper factors, what proper factor means, so anything that's not including the 1 and the number itself. And we know that the prime 1 is not a prime, and how to get the number of subsets within a set, and the proper number of proper subsets within a set. Now we've also learned about the positive proper factors. So you exclude the 1 and the number itself. That's about it. The order of sets is what they call cardinality, and we obtain that through basically the size of elements within the set. That's without going back to the lessons. So we've done these questions, we've done them. So there's this activity, let's see what it is. This activity investigates how many subsets a set has. Okay. A subset is a set contained in another set. We already know that. It's like you can choose ice cream from the following flavors: banana ice cream, chocolate ice cream, vanilla ice cream. You could choose any one flavor, or 2 flavors, or 3 flavors. If that's not greedy, of course it's not greedy, man. Fair enough. Alright, it can be a set of 1s, 2s, empty sets, a set of 1 element. So a set with 1 element has 2 sets. Yeah, that's worth noting. Oh my god, I keep missing the mic. Should get a better stand. This example, so we've got like 1, so a subset of 1 and an empty list. Hmm. That's like 2 to the power of n. So it's like 4 to the power of n is h, and so on and so forth. Okay, so another pattern. Um, the empty set has just one subset. A set with one element. So it's still a set with an element has two subsets. So the rule here, yeah, power. So we can add this as a mean of to simplify matters for us, so we don't confuse the multiplication with the power there. Oh yeah, now this is what the Pascal means, huh? Okay, so they recognize. So the empty set has just one subset. A set with one element has one subset with no elements, and one subset with one element, so it's 1, 1. A set with two elements has one subset with no elements, and two subsets with one element. So it's one subset with two elements. There's one subset with no elements, okay, and two subsets with one element, and one subset with two elements. So it's 1, 2, 1. A set of three elements is one subset with no elements, three subsets with one element, three subsets with two elements, and one subset with three elements. So it's like you get the different patterns. I see what you're doing here. So this is the Pascal's triangle. They are the numbers from 1, 1, 1, 2, 1, 1, 3, 3, 1. Oh, I see what you've done there. It's very useful because now you can check if you have the right number of subsets. Oh my god, this is really interesting. To get the number of subsets from Pascal's triangle. This is interesting because if we take a look at the link here, one of the most interesting number patterns is Pascal, named after Blaise Pascal, a famous French mathematician and a philosopher. To build a triangle, start with one at the top, then continue placing numbers below it in a triangle pattern. One, it's like a podium. 1, 2, 1, 1, 3, 3, 1. So it's like that's how you do it. Okay, each number is the number directly above it, added together. Okay. First diagonal is of course ones. Counting numbers 1, 2, 3, 4, 5 has the triangular numbers, has the tetrahedral numbers. And then I know what that is. Oh, okay. Horizontal sums, powers of 2. Damn, this is like... Huh. There's a lot of stuff to this triangle. Oh my god. Yeah, I didn't know that Pascal's triangle had this many uses. Interesting. So that's Pascal's. So when you go like you have elements of 5, then you go like 32. You have an element of 1, then it's 2. And then if you go like I have 2 elements within my set, it's like 4. You have 3 elements, it's like 8. So to the power of 3, that's like 8. So in this case, set apple, banana, cherry, date, egg, Ely subset of length 3. It's like this should give us 32 because we have 5 elements. But let's see what he's doing here. For the set apple, banana, Ely subset of length 3. Okay. But there is only 4 subsets. How many should there be? Should be 32. Well, you're choosing 3 out of 5. So go to row 5. Row 5, 1, 2, 3, 4, 5. 5 position 3 of Pascal's triangle. 6. Remember, start counting at 0. Oh yeah, 0, 1, 2, 3, 4, 5, and then position 3. Okay. To find you need 10 subsets. Oh, okay, you need 10 subsets. You must think harder. Oh yes, these are the subsets. You need to have 10 subsets. But what's that like? Last subsets of length 3. Yeah, position 3, so it's like this is number of elements 0, this is 1, this is 2, and this is 3, this is 4, and this is 5. That what forms the 32. Oh man, this is really interesting. So this is the deal. Now if you have a set of 5 elements, then it goes like so we have the 5, so this is the ones and this is the index, so just hit 5 elements, the total will be 32 subsets. However, so we always start from 0, yeah, index 0, but if you decided to take, say, you just want to know the number of subsets of 3's, so it's 0, 1, 2, 3, or 1, 2, 3, 4, 5, 6, so 0, 1, 2, 3, so you should have 10 subsets if you decided to go with 3 elements. 10 subsets of type 3 elements, you should have 10. Then if you decided to have 4 elements, you should have 5. If it's 5 elements, you should have one subset only. Yeah, interesting stuff. Is there a way of calculating the numbers such as 1, 4, 6, 4, and 1 instead of looking them in the Pascal's triangle table? Using combinations. 4C1, 4C1, 4C2, 4C3, 4C4, 360. Okay. So what combinations is all about. So order is not important. Now we do care about the order if it's a safe 7 word to work. So in mathematics we use more precise language. When the order doesn't matter, we use combination. When the order does matter, we use permutation. Okay? Is an ordered combination. Okay, so just keep this in here as a note. Going back to this. Let's keep going. Permutations, combinations. This one hardest to explain. Three factorial. So is that what the combination is about? Factorial. 4 by 3 by 2. 4 factorial, that's 24 different ways. This one is without repetition. Oh my god, this is all different concepts and terminologies that have to be gone through separately. I need a little bit of rest, so I'm gonna pause here.